Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today we are going to discuss about electrical charges. In this video, we will focus on origination of electrical charges. In this video, we will also discuss the type of electrical charges, different properties associated with these charges. These charges in these properties mainly we will focus on the attraction and repulsive nature of these charges. Concept of quantization of electrical charges. Let's first discuss about the origination of electrical charges. As may you observe in daily life that if you rub the balloon to your cloth, then it will stuck to the wall. So what is the physics and logic behind this phenomena? In order to understand it, we have to restart this simulation. This simulation consists of three objects. One is the jacket, this is the balloon, and this is the wall. These three objects are made up of millions and billions of atoms. Here, the number of positive charges on the wall is equal to a number of negative charges, and hence the net charges on this wall is zero. Similarly, the net charge on the balloon is also zero, and the net charge in the jacket is zero, because the number of positive charges which is labeled as with red color here. So the number of positive charges is equal to the number of negative charges, and the net charge on this jacket is zero. So the net charges on these bodies are zero, due to which they do not attract each other and apply forces on each other. So if we apply the external force on this balloon and rub this with the cloth, so we apply some mechanical forces, mechanical external force in order to rub these two bodies. That external energy is used to transfer the charges between these bodies. Due to that force, due to that energy, the electron is transferred from the jacket to the balloon, and hence the positive charge leave on the jacket. Now, the number of positive charges, on the jacket is greater than the number of negative charges, and hence the net charge on the jacket, net charge on the jacket is equal to positive, because the positive charge is greater. So similarly, the number of negative charges on the balloon is greater than the number of positive charges, and hence the net charge on the balloon, net charge on the balloon is equal to negative charge. So there will be a force of attraction between these positive charges and negative charge, and therefore these two bodies attract each other as. The net charges on the jacket is positive and the net charges on the balloon is negative, and hence there is the force of attraction between these positive and negative charges, and these therefore these two bodies attract. There is force of attraction between these two bodies. So now what will happen if we bring this balloon towards this wall? Here the number of negative charges on the balloon is greater. So these negative charges repel the negative charges of the wall. So due to which the number of positive charges are leave here in this side of the wall. Here is the positive charges. Similarly, there is excess negative charges and the balloon. So again there will be a force of attraction between these charges. One is positive, this is negative charge, and hence these two charges will attract each other, and due to which the balloon will stuck with the wall. So this is the physics and logic behind this daily application we see in the daily life. We also may observe that if we walk for a long time on the carpet in your room, and after that uh, if you touch the knob of the door, you will be shocked. So what is the physics behind this? So here, if we apply the force on the carpet, there will be some force of attraction between our foot and the carpet, and due to that friction and that rubbing, the charges will transfer from one body to another body. Is So the charges are created when two bodies are rough with each other. Due to that friction forces, the charges are created on this body. In that case, the negative charges were created on this body. And when we touch the metal surface, as the metal is conductor, and the charges will go towards that metal, and hence there will be a spark between the finger and the knob here. From these two experiments, we conclude that the charges originated when two bodies rough with each other. So due to that friction forces, the charges are originated on the body. Similarly, here these charges originated, the net charges on the body come into picture when two bodies rub with each other. So this positive charge from the jacket we bring to the this simulation. Here is that positive charge which has created due to the friction force. If I bring that charge here, there will be some sort of lines creating from these charges in different directions. So we will discuss this later. These are actually electric field lines. So electric field lines are originating from this positive charges up to the region to which this positive charge have its effect. So these charges are these electric field lines are originated from this positive charge. Similarly, if we bring the negative charge, which is created on the balloon here, which if we bring that negative charge to this simulation, to this lab, so here the same lines are appear around this negative charge. In this case, the lines are towards this negative charge. We will discuss this later. So this was some basic intuition of the positive and negative charges. And now we will discuss how these bodies attract, how these charges attract each other. So for that we have another simulation. Here this simulation is actually designed for how the like charges repel each other and unlike charges attract each other. Here we have a positive test charge. I'm going to label this as a positive test charge. Test charge is actually the theoretical charge. So this charge is conventionally be a positive charge. Conventionally it will positive. So here if I'm going to select the negative charge from this box and bring that to here, so the large number of field lines will create around this negative charge. We will discuss this later, but these lines are actually directed towards this negative charge, and this positive test charge is actually comes in the region of these lines. In the region of these lines, therefore this there will be a force between these two charges. In this case, these two charges are unlike charges, mean that this is positive charge and this is the negative charge, and hence there will be a force of attraction between these two charges. So so here I'm going to start this simulation by clicking on this button here. So the simulation has been started. So here this positive charge will attracted by this negative charge. So I think you may observe that this positive charge will attract you toward this negative charge, but at the beginning the motion of this positive charge is very slow, and that is increased with the passage of time, because if we come near to this source charge, the electric field intensity will increases, due to which the force on this positive test charge will increases, and hence the motion of this positive test charge towards this negative charge will increase. In the same way, if I bring the positive test charge, I am going to restart this and bring the positive charge from this box to here. So I am going to bring the positive charge to here. The large number of electric field lines are originating from this positive charge, and actually directed outward from this positive charge, and there will be and this positive test charge is actually come in the region of this positive charge. Actually, this is the region up to which these arrows are extended. So here, if I start this simulation, there will be a force of repulsion between these two charges, as this positive, this is positive charge and this is positive charge. These like charges will repel each other. So I'm going to start this simulation. So here there is a force of repulsion between these two charges. This is actually the in-depth intuition of the force of attraction and repulsion between these two charges. The one concept has been remaining in this lecture, which is called quantization of electrical charges. It means that the charges are quantized. This may be +1 charge, this may be +2 charge, this may be +3 charge, up to +n charge. And it also may be -1 charge, -2 charge, -3 charge, -4 charge, up to -n charge. These two are valid. This is valid and this is valid. But this is not valid if you say that I take 1.5 charge, or 0.25 charge, or 7.6 charge. So here it means if we take this in friction form, this friction form is not allowed while dealing with the charges. So this is invalid if you say so that I take plus or plus minus charges in this friction form. So the charges must be in quanta form. It must be in plus and negative whole number. So this can be justified as here in this simulation. We take a whole negative, one negative charge. This is other negative charge. This is the another negative charge. This is another negative charge. So we can say that the whole number of negative charges, the overall negative charges are 1, 2, 3, 4. Here is 4 negative charges. 4 negative charges. Okay, not in friction, but as a whole 4 charges. It is not 4.2, 4.1. Here it is 1 charge, 1 positive charge. It is actually 1 positive charge. It is actually 1 positive charge. And if we bring another positive charge here, these are other positive charge. So we will say that these are, we will say that these are 1, 2, 3, 4, 5 positive charges. Positive charges. So not will be in friction. but in whole number. This is plus 5 and this is minus 4. So this is the concept of quantization of charge.